Welcome all. Today we will discuss beam area or beam solid angle. In relation to this beam area, we will start with concept of radian and steradian. We will also do some numericals for better understanding of these topics. So let us start with this radian and the steradian. Now you can see here, this is a circle having a radius r. So this is a center point, this radius is small r, and this is a sphere. Okay, this is a circle. Okay, circle define the radian, and this is sphere, this define the steradian. So this is again a sphere of radius r, and if we define this radian, what is radian? So if we define one radian is defined as the plane angle with the vertex at the center. Okay, this is the center, so vertex at the center of a circle of radius r. Okay, this is having the radius r, that is subtended by an arc whose length is r. Okay, so let us say take an arc here. So length r is, if this is length r, so this angle, okay, if this is r, if this is equal to r, so this angle is 1 radian. Okay, so 1 radian is defined as a plane angle with vertex at the center. So vertex at the center of a circle of radius r. The circle is having radius r, that is subtended by arc. This is an arc whose length is r, so that will be 1 radian. Now we know that this circumference of circle is 2 pi r. Circumference of circle is 2 pi r. Then there will be how many radian in a circle? That will be 2 pi r divided by r. So we have 2 pi radians in a circle. Similarly, if we want to define steradian, so for steradian, this was an arc. Okay, this was the arc in the case of circle when we have found 1 radian. Now in case of a sphere, we have taken again this center as a vertex. So now in place of arc, we have a surface by which this angle is subtended. Okay, so this will be like that. Now we have surface. So one steradian is defined as a solid angle. Now in place of angle, because we have a sphere now, so we will in the 3D it is called as a solid angle with the vertex at the center. So we have taken the center of a sphere of radius r is subtended by a spherical surface. This is spherical surface. Area equal to a square. Okay, this surface is equivalent to this square having the area r square. Okay, square with the each side of length r. So this is a square, this side is r, this side is also r, so the area will be r square. So let us repeat it once again. One steradian is defined as a solid angle with its vertex at the center. So vertex at the center of a sphere of radius r, small r, is subtended by a spherical surface area equal to, now let us repeat it once again. One steradian is defined as the solid angle with its vertex at the center of a sphere of radius small r, that is subtended by spherical surface area equal to that of square with each side of length small r. So this is steradian. So we have to deal with this area. This is spherical area which is equivalent to area of a square. So if we want to calculate this, and if we want to plot this in 3D, so that will be look like this. Now this is again a spherical coordinate system having coordinates r, theta, phi. If you have some problem in this spherical coordinate system, you can see my previous video on orthogonal coordinate systems. Okay, so you can have a good idea. It is in easy language, and this easy method is given to understand this spherical coordinate system. So you can see that video. Now for the time being, we have we are talking about this area. This is the area we need to find out. So now here this x, y, z axis. So this is a 3D plot. Now this is phi is equal to 0 here. So phi is increasing in this direction. Theta is equal to 0 is here. So this is a strip. This is a strip having area 2 pi r sine theta r d theta. This is the area we need to find out to calculate this steradian. Now this area is r square sine theta d theta d phi. So we can write it in form of solid angle. So solid angle will be equal to what? It is given by this, it will be given by d ohm solid angle is given by this d ohm, that will be equal to what? Sine theta d theta d phi. So this is solid angle, and how it is related with this area, that will be equal to dA upon r square is equal to what? The sine theta d theta d phi. So that will be equal to this solid angle. Okay, let us move to the previous slide. So now here this surface area of a sphere is 4 pi r square. The radius is small r. Then if this the surface is having a area r square, then we will have 4 pi steradian SR, steradian in a sphere. Okay, we have already discussed we have 2 pi radian in a circle. Similarly, we have 4 pi steradian in a. Now if we need to find out area of sphere, so we have to take this strip. If we integrate this strip for the value of theta, then we can find out area of a sphere. So area of a sphere is given by, that will be equal to 2 pi r square integration 0 to pi sine theta d theta. If you solve it, you'll get 4 pi r square. So this is the area of sphere. Now here this we can say that 4 pi is equal to solid angle. 4 pi is solid angle. So what is this 1 steradian? 1 steradian is equal to 1 SR. SR is abbreviation to steradian. That is solid angle of sphere divided by 4 pi. And how it is related with radian? Now 1 radian was 2 pi, 1 steradian is 4 pi. So 1 steradian is equal to what? 1 radian square. We can write this because 1 steradian is 4 pi solid angle and this 1 radian is 2 pi. So 1 radian square is equal to 1 steradian. So put this value here. So we can write this 180. We can write this radian by this 180 by pi square. Okay. And degree square. So put this value and solve it. You will get 3283, approximately 3283 square degree. This is square degree. Okay, this is the unit of solid angle. We have already discussed it. Square degree. This is the unit of solid angle. Now if we, this is the 1 radian. If you want to find out 4 pi steradian, just find out 4 pi steradian. That will be equal to what? 4 pi into 3283. That will be approximately equal to what? 41253. Square degrees. And this is the solid angle in sphere. This is the solid angle in sphere. So now just talk about this beam area. Beam area or solid beam area. Solid beam area of an antenna is given by integration of normalized power pattern. Okay, so this beam area or solid beam area is integration of normalized power pattern over a sphere. So let us say this normalized power pattern is this. Okay, it has been normalized with respect to maximum value. So this P and stand for normalized, that is equal to power in particular direction divided by its maximum value. So this P and theta phi is normalized power. So if you want to calculate this beam area or beam solid angle, that will be the integration of normalized power pattern over a sphere. So you can write this beam area is given by ohm, that will be equal to integration over sphere for phi is equal to 0 to 2 pi. Okay, because this phi will vary from 0 to 2 pi and theta varies from 0 to pi. So this integration of this power, normalized power, sin theta d theta d phi. So we can also write this as in terms of solid angle, we can write it as 4 pi. In terms of steradian, we can have that value, because this sine theta d theta d phi is d ohm. We have already discussed it, so that will be in steradian, and this is beam area. Okay, so beam area is a solid angle. This beam area is a solid angle through which all the power radiated by the antenna, and that would stream if p theta phi maintain its maximum value over A and was 0 elsewhere. Thus the power radiated is so this beam area OM A is the solid angle. This is the solid angle through which power radiated by antenna would stream. Okay, this is the solid angle. All the power radiated by solid angle stream if theta maintain the maximum value over and was 0 elsewhere. This is the power. This is solid angle, so power radiated, it is given by okay, this is a power in a particular direction, so total power radiated will be equal to multiplication of power radiated in particular direction and this solid angle. Now this beam area of antenna can often be described approximately in terms of now if this phi HP is half power beam width in phi plane and the theta HP is half power beam width in theta plane, so we can also give this beam area in terms of these theta HP and phi HP. So approximate value of this beam area will be equal to phi HP and theta HP. So this relation also hold. We will use it time and time again in the coming sections. So, and it is also true total radiated power. So power radiated is equal to what? This value P theta phi and this solid angle, sorry, beam area. So this relation also here. Let us solve some numericals to better understand this beam area. It is given that E theta is equal to cos square theta and the theta varies from 0 to 90 degree. So if we want to find out this OM A, we know that this is equal to 0 to 2 pi. This is the value of phi. 0 to pi, this is value of theta, and this p theta phi sine theta d theta d phi. Now if you want to this power is what, how this power and electric field related. The power is E square. Okay, so square of this will give us, it implies that will be equal to 0 to 2 pi 0 to pi. So this will be cos raised to power 4 theta, and this term as it is sin theta d theta d phi. So if you solve it, you will get by solving this, for this integrated respect to this, there is no phi here. Okay, so phi we can easily solve for phi. Okay, then we can easily solve for theta. So after solving it, you will get minus 2 pi. This minus 2 pi is from this phi d phi. Okay, no phi variation is not here, so the remaining is theta variation. So for theta variation we will have, if we solve it, cos phi theta 0 to pi by 2. Okay, limit will change now because our theta is varying from 0 to 90 degrees, so 0 to pi by 2 only. Okay, no variation from this pi by 2 to pi. So this will be like this. So if we solve it, put this limit and solve it, we'll get 2 pi by 5. That will be 1.26 steradian. So this is how we can solve this type of problem. Now another way of solving this problem is by using this relation. We have also studied this relation, that will equal to phi theta. Okay, and so this theta HP can be found by using this relation. Cos square theta is equal to 0.707. Okay, if you solve it and found this theta, that will be equal to 33 degree approximately. And what will be this theta HP? That will be equal to twice of this, 66 degree. Similarly, this phi HP will be equal to 66 degree. Now multiply these two, you will get 66 into 66, that will be equal to 4356 square degree. Now we can convert it into steradian. How? By dividing it by 3283. So that will be equal to 1.33 steradian. So this is approximately equal to this 1.26 steradian. So this is another method of solving beam area. So let us solve another numerical. Here it is given that a range of theta is given 20 degree to 40 degree, and a range of phi is also given 30 degree to 70 degree. So find the number of square degrees in the solid angle on a spherical surface that is between this theta is 20 to 40 and phi is 30 to 70. So solution will be like that. Let's draw it. So that will be like this. If we draw it, okay, so this is the variation of theta, and this is the variation of phi. Okay, theta varies in this direction and phi will vary in this direction. So this will be 32, phi is varying from 30 to 70, and theta is varying from 20 to 40. So this will be like that, this variation, this 20 to 40, theta varying like this, and this is the variation of phi. Okay, so now you can calculate this solid angle, that will be equal to phi 30 to 70, theta 20 to 40, d phi, d theta, and sin theta. Okay, so by solving it we will get that is equal to 0.121. This is very simple to solve. Steradian. And number of squared, we have to find out this in number and square degree. So this is in steradian. So we have to multiply it with 3283. Okay, that will be equal to 397 square degree. Okay, this is very simple. So this is how we can solve the solid angle problems.